Okay, so the first part of Lab 8 has very little to do with analog to digital converter. It's left over from Lab 7, but I thought Lab 7 was too big. So I put it in Lab 8, and we're going to use it in Lab 8 though. We have some routines that if you have a variable and you need to print it out, like in a loop, and you do something like for I equals 0, I is less than or equal to 15, I plus plus, and inside the loop you say something like serial transmit us8 I, and serial transmit string or transmit character, return character. Squiggly brackets. So this code in the lab will print out 15 numbers. 0, 1, 2, 3, 4, 5, 16 numbers, 0 through 16. Yeah. But it prints it out in hexadecimal. But if you want to print out in base 10, there's no routine for that. And so in Lab 8, this serial transmit base 10 subroutine is given. And what I asked you to do is convert this from a us8 to a us32. So it can print out larger numbers. So the problem with the us8, right, the maximum value that you could print is 255 because the us8 is 8-bit. So we need to convert this to a us32. In order to be able to do that, you're going to need to understand how it works. So if you don't understand how this works, and I just say, hey, just do this, and you're a glutton for punishment, it takes 3 hours. But I don't want it to take 3 hours for everybody. So when we have a string come in, or when we have a value come in, let's say we want to convert the value 123. So we have some variable called value. So value is equal to 123. Okay, so value is 123, and our goal is to print out, I'm going to remind, so value is a USA, right? And US8 means I have 8 bits. So those 8 bits are 1, 2, 4, 8, 16, 32, 64, 128. So if I want to convert this to binary, it would be not 128, that would have to be 0. It's too big. But we need 64. 64 plus 32 is 696, so we need that. Plus 16 is 2 carry the 1 is 112. So we need the 16 plus 8 would be 120. So we need 8. Plus 4, that would make 124, it's too big. So we need 3 more, 1, 1. So that's the value 123 stored in an 8-bit register, converted to binary. So that's what value is, right? Everybody knows that. 8 bits, USA, that's all I got, 8 bits. But what we want to print out is the ASCII value 1, then the ASCII value 2, then the ASCII value 3. If you recall, the ASCII value 1 is actually the hexadecimal value, 31. This is 32. This is 33. Those are all the hexadecimal values. So how do we get one 8-bit value and convert it into 3 ASCII value? And that's what this routine here does. So the value comes in as 128. For the rest of this, we actually don't even have to think in binary. It's all in base 10, which is good because we all know base 10 very well. It's going to require some division and long division where you have remainders, and we need to keep track of how many characters we've converted, and that's going to be our count. And when we do our division, we're gonna store the remainder of the division in a variable called remainder, and then those characters that we're going to try to get to, we're going to store them in this array of 3 characters. Why did I choose 3 here? Any guesses? Some people have done it. Right. So the largest 8-bit value, so we have an 8-bit value here, so the largest 8-bit value is 255. So we're going from 0 to 255 for an unsigned 8-bit variable. So if our largest value is 255, that means the largest number we're going to print out is only 3 characters long. The number 2, the number 5, and the number 5. Okay, count is going to keep track of which letter we're on, or which number we're on. And like I said, the remainder is keeps track of our remainder. So a funny thing happens though. If our value that comes in is 0, we don't need to do any conversion. All we need to do is print out the number 0. So the first thing this does, this little subroutine here, is it says, this is our value that's coming in that we're trying to convert. If this value that came in is equal to 0, transmit the character 0. So if it's equal to 0, transmit the character 0. So if our value came in as 0, we would transmit 0, right? So this guy, right, overstretching my limits of the screen. So the value 0 is the binary number 00000000. The ASCII value 0 is the binary number 001130000. So if this comes in, we're transmitting this. 2 very different values. I'm going to write down our other variables that we have up here. We have remainder, and we have count, and we have ch0, 1 and CH2. Remember, if you have an array that is initialized with a 3, that means there's 3 values and they start at 0, 0, 1, and 2. So you have 3 values and they start at 0. So these are all our variables that we're going to have in this function. And I'm writing them over here because they're going to change as we analyze this function. Anybody have any questions up to this part of the function about what it does? Everybody have a good understanding? Pretty straightforward up to this point, right? If the value is 0, print out the letter 0. That's all it does. These declare some variables, but we haven't done anything with them. But if the value that got passed to this function is 0, we print out 0. So this part's easy. So I'm going to scroll up so we can look at the bottom part. So there's the else. See the whole thing. So if the value that came in is not 0, any value other than 0, and in our case we said 123, then we're going to go into this else. And the else is all in between these brackets. So the first thing that we come to is a while loop. And it says while the value is greater than 0, go into this loop. Go ahead and continue looping. So value is currently 123. 123 is greater than 0, so this statement is true. So we go into the loop. And the first statement says the remainder is equal to the value %10. Now, this is the first time you guys have seen this in this class. The percent is called the modulo operator. I'm not sure if it's spelled right. Anybody a good speller? But close enough. The modulus operator basically takes this value, divides it by 10, and returns the remainder. So this whole thing returns the remainder of 123 divided by 10. 123 divided by 10, back to second grade or third grade. It's probably like third grade, fourth grade, right? So 123 divided by 10 is 1. We could put 10 in here, bring the 2 down, 23, the 2 in there. 2 times 10 is 20. 23 minus 20 is 3. And so our answer is 12, remainder of 3. The remainder is now equal to 3 in our analysis of this program. Count was initialized at the beginning. What's it initialized to? 0? I believe you, but I want to put it back on the screen, just so everybody else believes. So count got initialized to 0. Okay, so count started out 0. So the next line of code says ch count, and remember count right now is 0. So ch0 is equal to the remainder plus the ASCII value 0. The ASCII value 0 is 30. This ASCII value here is 0x30 in hexadecimal. The remainder is 3. 30 plus 3 is 33. And 33, the hexadecimal value 33 is ASCII 3. So ch0, we store the ASCII value 3. Then we say value is equal to value divided by 10. Well, we know what value divided by 10 is. It's 12. And this is integer division, so the remainder is just truncated. So value is now 12. So value was 123, now it's 12. Then count plus plus, this means the same thing as count equals count plus 1. So count plus plus just increments count. So count was 0. 0 plus 1 is 1. So count becomes 1. And then that's the end of the loop. So we go back up here, and while value is greater than 0, value is 12. 12 is greater than 0. So this statement is true. So we go into the loop, and we do division again. And now, instead of 123, we have 12. 12 divided by 10 is 1. The remainder of 2. So our remainder is equal to 2. Remainder is now 2. Count is now equal to 1. So ch1 is equal to the remainder plus 0. 0 is 30. Remainder is 2. So this becomes 32. 32 is the ASCII value for the number 2. So ch1 becomes 2. Value is equal to value divided by 10. So 12 divided by 10, we already know the answer. It's 1. The remainder is truncated. So value becomes 1. Count becomes count plus 1. Count becomes 2. And we get to the end of our loop. We go back up, and it says, well, value is greater than 0. Value is 1. 1 is greater than 0. So this statement is true. And if this statement is true, we go into the loop, and we do the modulus operator. So we need to do 1 divided by 10. 1 divided by 10 is 0, the remainder of 1. So the remainder is now equal to 1. Count is now equal to 2. So ch2 is equal to the remainder plus 0. 0 is 30. Remainder is 1. 30 plus 1 is 31. 31 hex is the ASCII value, the number 1. And that gets stored in ch2. We increment count. Count is now 3. We get to the bottom of the loop. We've skipped this part. Value equals value divided by 10. So value equals value divided by 10, that's 0, so the value becomes 0. So we get to the end of the loop, come back up here, value is now 0. Is 0 greater than 0? 0 is not greater than 0. 0 is equal to 0. So this statement is false, and so we do not go back into the loop, come down here to this next loop. So count is now 3, and it says while count is greater than 0, count is greater than 0, go into this loop. Count is 3, so 3 is greater than 0, this statement is true, so we go into the loop. Count minus minus subtracts 1, so count becomes 2. And we transmit the character CH2 because count is 2. So CH2 is 1. So on the serial terminal, you'll see the number 1 print out. Get back up here. It's count greater than 0. Count is 2. Increment count. Count becomes 1. We print out CH1, which is the value 2. Come back up here. It's count greater than 0. Count is 1. It is greater than 0. Decrement count. So count becomes 0. We print out CH0. CH count. Count is 0. CH0 is 3, so we print out the number 3. Come back up here. Is count greater than 0? No, count is equal to 0. So we don't go into the loop and we exit the function. That's the end of that function. Okay, so we get rid of these notes. We look at this function. If we want to convert this to a us32, what will need to change in this function? The array? What value will it need to be? You need to know the largest value a us32 is, right? It's in the notes. It's in the lecture notes. 4 billion something. 4 billion and some change. Okay. Any questions on that? Everybody understand it? Pretty simple, huh? Maybe not. But the good thing is, I recorded it just now, so I'm going to put it up promptly because I actually have it recorded. Hopefully, well, your number is going to be bigger, so you need some larger value here. You need to. Why is that a 3?
Because it can only go to 255.
Right. And 255 is how many?
Set it whatever you want, or
You could.
or do you want to go?
You only have 4,000 bytes in the pick. Right? So you can't set. You could set it to 5,000, but you don't have that many. You don't need 5,000. You probably don't need more than 10. You probably need less than 10. I don't know. So, but if you don't change this, you may have problems. I needed to change this, of course, and the function prototype.